Okay, so you've seen the title of the video, and you've looked at the runtime, and if you haven't already, you're looking at it now, and you're wondering to yourself, how could it be that there is still this much to say about the diodes in the Klon Centaur? So much has already been said and written about these diodes. I know this because I've been researching this video for a few weeks, and I've crawled through countless forum posts, some 10, 15 years old. My brain is officially mush, and at this point I feel compelled to just get this information off my mental books. So I don't have an answer to the initial question, but nevertheless, this video is in fact all about the germanium clipping diodes in the Klon Centaur. I'm breaking this video up into 3 parts. Part 1, we're going to go over the history of the Klon. Who made it? When was it made? Why was it made? Going into all the colorful events in the Klon's history. And we're specifically going to talk about the diodes and how that plays into the story that is the Klon Centaur. Part 2, we're going to cover diodes in general. What do they do? How do they work? How are they used? What do we know specifically about the diodes in the Klon Centaur, which isn't much. We're going to talk about some misconceptions about what we knew about the Klon Centaur diodes and how that's led to some potentially interesting results. And then we're also going to talk about some replacement diodes that have been chosen for use in Klon Centaur clones. And then finally, we're going to wrap up with an exploration of a infrequently discussed but important fact of the Klon Centaur circuit, and specifically the usage of the diodes that has the possibility of making the hype around the pedal, around the diodes, seem even more ridiculous than it already does. So if any of that sounds interesting, or by some miracle all of that sounds interesting, grab your favorite beverage, saddle up, do whatever you have to do to mentally prepare for an unreasonably long video about a super specific nerdy topic in guitar pedal history, the germanium clipping diodes in the Klon Centaur. Enjoy. So the story of the Klon Centaur. Now, even with as long as this video is, I can still at best only do a synopsis of the story of the Klon Centaur. This journey of this pedal is worth a mini documentary of its own, and I am not an expert, and there's going to be things that I probably don't get quite right and probably miss some important things, but I think it's important to go over this. The story of the Klon and the Klon diodes are intimately linked together. To that effect, I'm going to try and tell this story and balance timeliness and precision. So it all starts in 1990 in Massachusetts with a gig musician named Bill Finnegan. He's got his Telecaster, he's got a twin reverb. He's running into an issue where some of the gigs he plays, he can't turn up the twin loud enough to distort. This is a problem that persists to this day. Twin reverb is a very loud, clean amp, and you have to crank the thing to very loud levels to get it to the tubes to clip. So Bill seeks out a solution to that, which is essentially the same as it is today, which is using an overdrive pedal to boost the signal, increase the amplitude, and potentially add some clipping of its own to the signal. In that day, 1990, it's not like it is now, where you can go out to any guitar store and have 100 choices of overdrive pedals. In the 90s, there were a handful. The most popular of which was the Ibanez Tube Screamer. Bill does exactly that. He goes and he tries a couple of Tube Screamers, and he doesn't like them. He tries 2 TS9s and doesn't like them. He tries a TS808. He likes it a little more, but still not right. And so at this point, he realizes he's going to have to design something to get what he wants. And what he wants is a overdrive pedal that doesn't meaningfully change the tonal quality of his setup. It just pushes his amp a little harder, gives him a little bit of clipping, and enhances what's already happening. So this is sort of the beginning of the idea of a transparent overdrive. Something that gives you boost and clipping of some sort, but doesn't change the character of your sound. So that's 1990. Over the next 4 years, Bill works with 2 MIT engineers. He's in Massachusetts. MIT is the sort of obvious choice to work with electronics. So he works with 2 different engineers from MIT over the course of 4 years designing the Klon Centaur. By 1994, he feels the circuit is as good as it's going to get, and he, right at the end of 94, he starts selling the Klon Centaur. Sales start pretty slow. He's selling to friends and acquaintances and He's doing some consignment in local music shops. You know, it starts pretty slow, as all pedal businesses do. But it continues to grow, and word of mouth spreads. People start buying them. Bill builds each one by hand in an apartment. It reaches a certain point where Bill cannot keep up with the demand for the pedal, and so a waiting list starts. So now we're going to smash cut to 2007. By 2007, the Klon Centaur is very popular. It has risen in price twice now. It started at $225. It went to $279. And then it went to $329. So we're in 2007. Klon Centaur is currently $329. I should mention, if you want to buy a Klon Centaur, you can't just like go on some website and order it. Chances are a local dealer is not going to have it unless you happen to live near one of the few dealers that Finnegan worked with. So you had to just call up or email Bill Finnegan, and you would talk to him about it, and he would, you know, say if the Klon Centaur is right for you, and then you could order one. You send him a check, he sends you the pedal. By 2007, the time between you sending the check and you getting the pedal was about 8 or 9 weeks. A lot of people obviously didn't want to wait that long, and so people were selling their used Klons on eBay for several hundred more than the current selling price, $329. Used Klons could be anywhere $400 to $600, $700, $800 at that point. So those are your options in 2007 for picking up a Klon pedal. You talk to Bill and order one for $329 plus shipping, and wait 8 or 9 weeks for the real Klon from Bill, or you buy a used Klon off eBay for several hundred more. Jumping to 2007 wasn't arbitrary though, because there's a alternate thing happening in 2007 that's important to the story. In 2007, the Klon, as we already said, has gained a bunch of popularity, and there starts to be a bunch of interest on the DIY forums as to what the Klon is, what it does. Ton of speculation, nobody knows. There is a forum called freestompboxes.org, and a group of 8 people who are basically strangers to each other except through this forum, this hobby. These 8 strangers pool their money together and purchase a used Klon Centaur off eBay for the purposes of tracing the pedal and releasing the schematic. At this point, I should mention that the Klon Centaur is unique in boutique pedals in that Bill went to the extent of putting goop or black epoxy on the PCB so it couldn't be visually inspected. Presumably this is done to protect the circuit, to hide its contents, its makeup. Sometimes goop can be used for more nefarious purposes, like disguising the fact that you copied someone else. That's not the case for the Klon Centaur, but it's possible. For whatever reason it was done, the circuit board in a Klon Centaur has black goop on it. And so the plan was at freestompboxes.org, they pooled their money together and they purchased the used one off eBay, and they were going to trace the circuit and release the schematic. There's some discussion over how public it should be, but ultimately the plan was to just release it publicly. The story of that Klon pedal that was purchased for tracing is a whole thing on its own. But to put it quickly, it was purchased, the Klon was in France, it was purchased, it was then sent to the US, where it was then going to be turned around and shipped right back to Europe, to Austria, to be traced, because the person who they depended on to trace it, or I should say the person who was picked as the best person to trace the pedal was in Austria. Unfortunately, that person had some medical issues, so the pedal ended up staying in America. Eventually, it ended up in the hands of a user named Solsonic. And Solsonic was the one who actually traced the Freestomp Boxes Klon. Took the goop off, traced it out, measured the values, etc. All in all, it took about a year from when the pedal was purchased to when the first copy of that traced schematic was released, which was right around April of 2008. So that's what happens. Freestomp Boxes, they buy a Klon, they trace it out over a year, it gets released April 2008. There's a few modifications that need to be made to that schematic, and it happens over a course of a year. Finally, in May 2009, we get the final corrected version of the Klon Centaur schematic. And that is the schematic. That is the one that everybody knows, everybody uses to make their Klon clones. If you go looking for a Klon schematic right now, that's the one you're going to see. There was some talk that maybe there were a couple resistor values that were swapped around, but it turned out that wasn't true. So the May 2009 schematic is the real and true schematic of the Klon Centaur, allegedly. I put allegedly there because it's still a little bit up in the air whether or not the Klon Centaur has changed schematics. Some people say it has, some people say it hasn't. But there is a good deal of trust that is put into that schematic. And for the purpose of this video, I am going to consider that an accurate schematic for the Klon Centaur. That Klon that was traced is serial S698, Silver 698. And it is my opinion that that is the most famous Klon that most people have never heard of. Because that Klon spawned that schematic, and that schematic has been used for so many clones, or Klon clones with a K, all over the world, so many different manufacturers. Chances are, if you own a Klon Centaur that's not a real Klon Centaur, it's probably based on S698. So now we're into 2009, middle of 2009. The schematic for the Klon Centaur is finally known. It's known what the Klon Centaur is. It comes out that it's not a tube screamer. It's not a, a modified blues driver, DS1, or any of the other conjectures. It is a truly, at least as far as guitar pedals go, it's a truly original circuit. It does some unique things. I think it's fair to say that Bill Finnegan was quite upset that the pedal was traced and the schematic was released. He would talk frequently about his livelihood being threatened by the schematic being released. But it is my opinion that it was closer than that to him. It was more, this was his baby, and the secrets were being let out. And while he has never said or written specifically that the release of the schematic for the Klon Centaur played a part, you would be foolish to think that it didn't contribute when 6 months after that schematic release, so May 2009, 6 months after, in December, Bill Finnegan calls off selling the Klon Centaur. End of December 2009, Klon Centaur stops being sold. He's still making more of them because there's people on the wait list, but that's when the Klon Centaur, that's when, the music stops. Of course, that's not the end of the Klon Centaur story. Over the next couple of years, Bill is working on a replacement for the Klon Centaur, which is the KTR. It takes a few years to get it right. There's some setbacks. Hurricane Katrina destroyed some product and some production material. There's problems with different manufacturers and PCB designers. Bill was hoping to have the thing out by 2010. It took till end of 2012 to actually get units out the door. The KTR finally did happen. It was a new version that was all surface mount. And almost all surface mount, but it had a standard DC jack, it had switchable buffer bypass, a standard enclosure. Important to this video especially, the KTR still included the real original Klon Centaur germanium clipping diodes. That stayed consistent. So that's the end of the story of the Klon Centaur. Obviously there's not enough time to go into everything. I may have missed a few details, I may have got a few details wrong. Like I said, I'm not an expert, but this is the part of the story where I have to start making some more opinionated statements. That's specifically about the diodes and why we care so much. There are a ton of pedals that use diodes for clipping. Some in the same way that the Klon Centaur does. MXR Distortion Plus, that has clipping diodes the same configuration as the Klon does. We don't talk about those diodes. The Tube Screamer uses clipping diodes. The Proco Rat uses clipping diodes. Ton of pedals use clipping diodes, but for some reason the Klon Centaur diodes are special, and they do have some more objective things about them. We're going to go into that in part 2 a little bit more, but they're special. You can't really find them around, allegedly. They are new old stock components. They're not really made anymore. It is my opinion there's something bigger than that, which is that the Klon Centaur diodes became this benchmark, a talisman of the difference between a real Klon Centaur and all of the clones. It's no secret that once that schematic was released in 2009, the market for building clones of the Klon Centaur exploded. It's just common knowledge that everybody and their grandma makes a Klon clone. Think of any big pedal manufacturer, they make one. You can understand why it might become important for certain people to want to make sure that people believe that Klon clones can't be the real thing. You can't look just at all the components. The Klon's pretty much made up of standard stuff, resistors, capacitors, op amps. You could look at perhaps the builder, but also, what one human likes is pretty subjective. But here we can look at these diodes and we can say, these are special. They're uncommon, they're not made anymore, they're very scarce, as Bill said. People started to latch on to these diodes. Bill was one of these people who said, if your Klon clone does not have the real diodes that I picked, and this is Bill speaking, the real diodes that I selected, if your Klon clone doesn't have them, guess what? It's not a Klon. That hype, I don't want to say manufacturer hype, but that hype is why we talk about those diodes so much. There are people who may be trying to protect their investment of having their real Klon, and they don't want to believe that other people can have the same thing. without paying the money they did, or you know, maintaining the prestige or waiting for it or being early or whatever. And then you have Bill Finnegan, who you would understand he might, you know, this is his baby, it's his one pedal. He spent 4 years designing it. He might want to protect the heritage or the prestige of his pedal. And the diodes became that scapegoat. It became that thing that people latched onto and said, this is the difference. Some of these have the real diode. Those are the Klon Centaurs. Some of these do not. They're something else. And as we're going to explore in part 2, it wasn't as simple as just, okay, I'm going to go buy the right diodes and put them in my clone. For reasons we'll go into it, that wasn't possible. I think with that, we're going to move on to part 2. And we're going to take a look at diodes in general, what they do, how they work, and what we know about the Klon Centaur diodes. All right, so now we're going to look at the electronic characteristics of a diode, how they work, etc. So diodes. Diodes are a type of electronic component called a semiconductor. Semiconductor just means that under certain conditions, the component will conduct electricity or allow electricity to flow. Under other conditions, it will block the flow of electricity. Diodes are generally considered one of the simplest semiconductors, and the concept is sort of like a one-way valve. So current can flow through the diode in one direction, but it cannot flow back the other direction. The conditions under which the diode will conduct or not conduct generally refers to the polarity that you hook up a voltage source to the diode. On the anode side of the diode, if you connect a positive voltage, and on the cathode side of the diode, you connect a negative voltage, that would be forward biasing the diode, and it would allow current to flow. If you were to do the opposite, if you were to connect negative to the anode and positive to the cathode, that current will be blocked. That's called reverse biased, and it blocks the flow of electricity through the diode. That's the operation of an ideal diode. Real life diodes have break those rules at sort of the bounds of their capability, but generally speaking, that's how diodes work. It's a one-way valve for current. There are two semiconductor materials generally that diodes are made of. We have silicon, or Si, germanium, or Ge. These are physical representations. You should be seeing a slideshow now of different silicon and germanium diodes. Silicon diodes are generally smaller. They're generally opaque. They'll often be orange in color with a single band of black or some color. Or they can be gray or black with a silver band or blue. But generally they're not see-through. They are often made of glass, but sometimes they are either plastic or epoxy. Germanium diodes are usually glass. They're usually larger than their silicon counterparts. They are often what's called a point contact diode, which is what I depicted here. So that's point contact, which refers to the inner construction of the diode, where there's a small wire coming from the anode, which comes and touches the semiconductor wafer on the cathode side at a single point. There's another important distinction to be made between silicon and germanium, which is forward voltage, which is often represented as VF. VF for a silicon diode is approximately 0.6 volts. Forward voltage for a germanium diode is approximately 0.3 volts. Those are typical values for the forward voltage for germanium and silicon. What is forward voltage? Forward voltage is the necessary amount more positive the anode has to be than the cathode in order for the diode to actually start conducting. If you hook up a voltage source to a germanium diode, but you're only 0.1 volts above, if your anode is only 0.1 volts above the cathode, then the diode will still not allow current to flow. If you get to 0.3 volts or maybe a little before that, then the diode will start to flow. Even higher for the silicon, 0.2, 0.3 volts positive anode to cathode, still won't really flow electricity. You have to get up here to 0.6 volts to actually start flowing current. All right, let's expand more on forward voltage. So I have a graph set up here that is going to show the change in current through the diode as we increase the anode to cathode voltage. At the bottom here is forward voltage. At the y-axis is current. Y-axis is in milliamps, x-axis is in volts. So let's draw a typical silicon diode. This is what the curve of a silicon diode is going to look like. So that is the curve of a typical silicon diode. Note that current is still not flowing in this area here. Once we get to about 0.5 volts, then current will start to flow, but it's still somewhat resistive to the flow of current. Once we get to 0.6, now we have a very large increase in current and it shoots up, very low resistance in this area to current flow. Let's juxtapose that with a germanium diode. This is the curve of a germanium diode here. So this could be the curve of a very typical germanium diode. Two things to take notice of here. Number one, obviously the forward voltage of a germanium diode is lower, so the germanium diode will start conducting sooner. The anode only has to be 0.25, 0.3 volts above the cathode in order to start passing current. But also you want to notice that the steepness of the germanium diode is less. So this silicon diode really starts to shoot up quickly once we pass that forward voltage threshold, where for the germanium diode, it's more gradual. We can say this another way, which is that the nonlinear region of a germanium diode is much larger than the nonlinear region of a silicon diode. What this means is that the change in current for a germanium diode as you increase the anode to cathode voltage is more gradual, whereas once you sort of hit that threshold for a silicon diode, it really starts to shoot up quickly. Both forward voltage and the slope of the forward voltage curve play a part in how the diodes sound, especially in a clipping circuit like the Klon Centaur. One last thing I want to point out on this graph here is that while this curve represents one single diode, if we were to pick a point out at a couple different currents, say 1 milliamp and 5 milliamps, at 1 milliamp, the point on this curve for this whatever germanium diode appears to be about 0.325 volts. And for 5 milliamps, on this same diode appears to be about 0.5 volts. I want you to remember this because it will be important later. The same diode measured at 1 milliamp and 5 milliamps yields two different forward voltages. So keep that in mind. All right, so now let's talk about what we know about the Klon diodes. So it was already established that the Klon diodes are in fact germanium. We know this for a couple reasons. Reason number one, when Freestone Boxes was tracing S698, the forward voltage of the diodes was measured, and it was measured at approximately 0.35 volts. That would place it squarely in the territory of germanium. If it was a silicon diode in the Klon Centaur silicon diodes, we would expect this number to be closer to double that. The second way we know it's a germanium diode is by the physical attributes of the diode. I drew one of these earlier, but I'll draw it again. This is a reasonable drawing of the Klon Centaur diodes, and they look just like the point contact diodes I drew earlier. So the Klon Centaur has two germanium diodes that look just like this. The large black band, the little wire inside from the anode to cathode. There's of course two of these. The diodes in the Klon Centaur are set up in a symmetrical hard clipping fashion. So there's two opposite polarity going from the signal path to ground. We'll talk about that a little more in a bit. And the last thing we know with very high confidence is that the part number that Bill Finnegan used for the Klon diodes is 1N34A. Bill Finnegan said this himself years after the Klon Centaur had gone out of production. He confirmed that the part number is in fact 1N34A. This is a pretty much meaningless fact. The truth is that if you need a germanium diode for a general purpose project, it doesn't have to have especially high power capabilities or voltage withstanding or any special features like that. If you're just looking for a simple, regular germanium diode, chances are you're going to be buying a 1N34A. What that means is that there's a ton of them around. They all work a little bit different. They all look a little bit different. A whole bunch of manufacturers made them. Really, this tells you nothing about a diode except that it's probably germanium, which we already know. So this is really all we know for sure, or with very high confidence, about the Klon Centaur diodes. We know some more like stories that aren't like the electrical characteristics of the diode. For example, the story that Bill tells about how he picked his germanium diodes is that once the Klon Centaur was basically designed, he bought a whole bunch of different germanium diode styles. He says like 70 or 80, tried a whole bunch, through some listening tests, and determined that most of them didn't sound right in the Klon. A few of them sounded okay, and one of them sounded good. That's the one he used. He then went and purchased all of them he could find, and he's been trying to find more for years and has failed. So maybe that's another thing we know, is that Bill pretty much, according to him at least, has all the remaining of this specific diode. But I want to talk more about the forward voltage of the Klon diode. So we already said that the forward voltage was measured on the Klon diodes when it was traced as 0.35 volts. Now recall, when we did our graph showing the forward voltage curves, it is possible to get multiple forward voltage readings for the same diode. And the factor that that depends on is the current. And so this causes us a big problem because generally speaking, we don't know the current at which this test was done when it was traced to get the 0.35 volts. Or do we? Well, we actually do, and I'll explain how. Typically, when we're testing diodes, a lot of people are going to use a multimeter. Multimeter is obviously an electronic testing device that tests a whole bunch of things: resistance, capacitance, direct current, AC current, or direct voltage, AC voltage, current. But often, multimeters will have a diode test feature. And so you'll take the leads out of your multimeter, like so. You'll hook up your diode, and you can measure the forward voltage of the diode. 0.3 volts, whatever. The multimeter here, when it's measuring forward voltage, typically a multimeter will measure at 1 milliamp. That is the typical test current for the diode test on most multimeters. And that would be great. If that's the one thing you use and you test all your diodes, then you can stay consistent and you can know one diode to the next in your collection. This is what they are because I'm always testing at 1 milliamps. The problem is that when Solsonic tested the forward voltage on those Klon diodes, they didn't use a multimeter. They used a special semiconductor analyzer called a Peak Atlas DCA 55. The Peak Atlas DCA 55, or just a DCA 55, is a semiconductor analyzer. It has the ability to test a whole bunch of different semiconductor devices. It actually has 3 leads. I'm just drawing 2 because that's all you need for a diode. But it can test transistors, diodes, thermistors, SCRs. You can test a whole bunch of stuff. But the big problem here is that the diode test on a DCA 55, or its big brother, the DCA 75, which is what I have, the diode test doesn't test at 1 millimeter like a multimeter. The Peak Atlas DCA 55 tests at 5 milliamps. I said millimeter, milliamps. Peak Atlas DCA 55 tests at 5 milliamps, not 1 milliamp like a multimeter. Hopefully now you see the problem is if you go on a journey of trying to find germanium diodes that have a matching forward voltage of 0.35 volts, like the original Klon diodes were tested at, and you use your multimeter to look for this number, you are going to end up finding diodes that have a further right forward voltage curve than the diodes that were actually in the Klon Centaur. Let me show you that. So we're just going to draw that graph again really quick. So here's our germanium diode again. So this is one germanium diode. We can test it here at 1 milliamp, and we can test it up here at 5 milliamps where Solsonic did it. So with your multimeter, this diode right here could test at exactly what you wanted, 0.35 volts. Cool, I just found a diode that has the same forward voltage as the original Klon diodes. Solsonic tested at 5 milliamps. That diode you thought was 0.35 volts and matched the Klon, guess what? It's actually 0.45 volts at 5 milliamps. So if you wanted to find a diode that actually matched the 0.35 volts that we now know is at 5 milliamps with your 1 milliamp tester, you need to find a germanium diode that hits this point here. You need to find a diode that looks like that. A lot less forward voltage. So I don't have any hard numbers on this as to how many people have been putting too high a forward voltage diodes into their Klons. But considering that I've never seen anybody talk about the fact that the forward voltage for the Klon diodes was tested at a lot higher current than we normally test diodes at? My guess is probably a lot of people, and probably fairly large people. Maybe not the biggest companies out there. Maybe they have the wherewithal to hunt down exactly where the 0.35 volts came from, or they've got a Klon or a KTR and tested them themselves. The fact of the matter is, if you want to find Klon diodes that match a forward voltage of 0.35 volts at something other than 5 milliamps, say at 1 milliamp, chances are you're going to be looking for a forward voltage maybe like 0.28 volts, for example, maybe 0.26, something lower. You could also set up a tester, some sort of test rig, in order to actually create 5 volts for the diode to actually measure 0.35 volts. So that's just one discrepancy with the forward voltage. All right, let's talk about some diodes that have been used to replace the Klon Centaur diodes in Klon builds. So we've gone over what we know about the Klon Centaur diodes. We know it's got a slightly high forward voltage at 0.35 volts for a germanium diode, and that's at 5 milliamps. We know the part numbers 1 and 34A. Don't know much more besides that. The number one diode right now that is recommended for Klon Centaur builds is the Soviet D9E. These aren't actually D and E, they're Cyrillic characters, but this is how it's identified. This recommendation came from Kevin at Build Your Own Clone. It was part of the project documentation for the Silver Pony. Silver Pony was a kit build, and I think it was also a pre-build for Build Your Own Clone, so you could order it just built or order the kit. It was pulled not long after it was introduced, and there was a whole controversy around that. That's another story, but the D9E was recommended by Build Your Own Clone as a good substitute for the Klon diodes. Forward voltage for the D9E, in my experience testing them, is about 0.4 volts, and that's at 5 milliamps with my Peak Atlas tester. Interestingly, 0.4 volts at 5 milliamps is probably going to put you pretty close to 0.35 volts at 1 milliamp. Now, I don't have any confirmation of this, and I don't know how Kevin was testing his D9E when setting up the Silver Pony, but it's possible that the 1 milliamp versus 5 milliamp discrepancy may be playing a part here. As far as I know, the D9E wasn't selected just for forward voltage. It was also selected during listening tests just for sonic quality. But either way, D9E is still the number one recommended substitute diode for Klons. Besides for that, you could try really any germanium diode. You do want to be careful for germanium diodes. A lot of times now, people will mistakenly sell or advertise Schottky diodes as germanium diodes. Schottky diodes and germanium diodes tend to have a very low forward voltage, like we've already talked about, approximately 0.2 to 0.3 volts. That can be true for both germanium and Schottky diodes. However, the way to test to tell the difference is you need to put more current through the germanium diode. You will see that the forward voltage rises more for a germanium diode once you head up towards like 8 or 10 milliamps, whereas for a Schottky diode, the forward voltage stays pretty low in the 0.5 volt or less range. So that's one way to tell. If you're ever testing germanium diodes and you're not sure if they're real and you want them for your Klon, not that you can't use Schottky diodes, you definitely can use Schottky diodes in a Klon Centaur. But if you want germanium, that's how you can tell. So some other choices that you could use, obviously, you can use any 1N34A. That's a germanium diode. Yes, it's the same part number as the Klon diodes, but as we went over before, that doesn't really matter. So many diodes have held this part number, and it's been made by so many different companies over the years. There's no guarantee that this is going to sound like Klon diodes. You could also go with other germanium part numbers like 1N270. That's a popular one. You could also go with other Russian diodes. There's D9B. There's D9K. Both those are germanium diodes that could be good substitutes. Side note, be careful with the Russian diodes. The band on those often indicates the anode, not the cathode, like we've seen with Western make diodes. Beyond that, there is no rule that says you have to use germanium. You can use silicon diodes. Silicon diodes like a 1N914 or 4148, same diode. These can be used in Klon diodes. The forward voltage is higher, right? Silicon diodes are at 0.6 volts. So you're gonna have more signal passing through before it starts to clip. So a little bit less clipping with a silicon diode, but you absolutely can use them as clipping diodes. You could use even a higher forward voltage diode like LEDs. LEDs of different colors. Remember, this D stands for diode. LEDs are diodes. And forward voltage for a diode, they range, but they're usually anywhere 1.5 to 2 volts. So you're going to get a lot more output out of your LEDs for clipping and less clipping overall. Some people have even tried using transistor junctions as clipping diodes. You could try transistors like an MPSA 18, a 2N3904, BC 549. You could try the base emitter junction for a clipping diode. In either one of those, just put base to emitter and then emitter to base, and you have your two symmetric, opposite polarity clipping diodes. You could try that too. Those, of course, would be more similar to silicon diodes than germanium. So up until September of 2021, the story of Klon diode replacements would have just been for clones. However, Bill Finnegan has said in a live stream he did in early September that he is actually running out of the true Klon diodes. He said that KTRs going forward were going to have some other diode, and he needed to tweak the Klon circuit, the KTR circuit, whatever, in order to use those alternative diodes and still sound like the original Centaur with the original diodes. As far as I know, it's still unclear what the tweaks to the circuit were, and it's also unclear what the alternative diodes look like. I've seen a couple pictures now, and hopefully they'll be flashing on the screen. Some with a single gray band, some with a gray and a red band, I believe. So right now it's still a bit of mystery what diodes those are going to be and what changes need to be made in order for them to sound like a real Klon, according to Bill Finnegan. But to wrap it up, as a general rule of thumb, if you're looking for a replacement diode for a Klon Centaur build, you're going to want a forward voltage of approximately 0.28 to 0.3 volts, and that's at 1 milliamp, so like a tester on your multimeter. Of course, the original test that Solsonic did would still stay true, 0.35 volts at 5 milliamps. You're going to want germanium, obviously. That's pretty much it. If you find something like that, that's a good start. The best case scenario here is to have a bunch of diodes on hand that you can try and just do some listening tests, see what sounds good to you. Because at the end of the day, all of these suggestions, the original Klon diodes themselves, they're all based on Bill Finnegan's ears and what he likes. He's said as much himself. That ultimately comes down to just personal preference. So best course of action here, it's a good start to go with these specs, but try some other stuff, see what you like. If it sounds good to you, then it is good. All right, so we made it to part 3 of the video. If you've enjoyed so far, I'd appreciate you hitting the like button and subscribing. Let's go over what we talked about so far. So we talked about the history of the Klon Centaur, who designed it, where did it come from, what are the timelines associated. We talked about the tracing of the pedal, who traced it, when was it traced, what happened, right, the explosion of the clone market. We also learned about why the diodes are so important to the Klon story, as that delineator between real Klon Centaurs and KTRs and all of the Klon clones. Then we talked about diodes in general. What do they do? How do they work? What are some important features of diodes? We talked about what we know about the Klon Centaur diodes, which isn't very much, and also some similar diodes that are used in Klon builds and what you might look for in a diode if you were looking for one for a Klon Centaur you're building. So for the third and final part of this video, I want to go over an interesting feature of the Klon Centaur circuit, which may be a bit controversial, isn't discussed that much, and has to do with the way the Klon Centaur is used most frequently by guitar players. This fact is going to affect every Klon Centaur, every KTR, every clone, and it really calls into question how much emphasis we put on the diodes. All of the hype surrounding it, the claim that they're magic, it really is going to make you think whether or not you should care about that. So, first off, I don't own a real Klon. They are extremely expensive. I do, however, have a Seriatone Centura, or a Seriatone, I say it weird, I'm sorry. Centura here is a very accurate reproduction of the Klon Centaur. It's got a very similar aluminum enclosure. PCB design is very similar. Components obviously are the same values. Does not have the original Klon Centaur diodes, of course. However, on this Centura, I did a modification to socket the clipping diodes, which means that I can pull in and out the clipping diodes by hand. And what I'm going to show with this Centura is that when you use the Klon Centaur as a clean boost, and by that I mean the gain knob rolled all the way down or no more than like 9 o'clock, treble knob to your preference, and output knob somewhere between 9 and 12 o'clock. When you use the Klon Centaur as a clean boost, the clipping diodes are doing nothing. They are out of circuit, effectively out of circuit. I want to be entirely clear. This isn't something that Bill Finnegan is like trying to hide. He has said as much at least a couple times, that exactly what I'm telling you now, which is that when you run the Klon Centaur as a clean boost, the diodes are not in circuit. But you don't have to take Bill's word for it, and you don't have to take my word for it. I'm going to do 2 tests here. The first one we're going to do is a listening test, and I'm going to set it up so that I can easily take the diodes in and out of circuit, and you'll be able to hear for yourself whether or not you hear a difference when the diodes are in and out of circuit. If that isn't enough, I'm also going to hook the Centaur up to an oscilloscope, and you'll be able to see there as I pull the diodes in and out whether or not they're having an effect on the signal. So let's get that set up now. We'll do a listening test first, and then we'll have a look on the scope. All right, set up to do a little listening test here. So we got the Centaur hooked up. Got a ditto looper going in the front of that with a little guitar loop I recorded. The pedal's obviously upside down, so this here is the gain control, the dual gang pot. I'm going to be manipulating that during this test, and you'll see me, I'll kind of signal like where the position of the knob is. And I've also got the germanium diodes here. So we did the socket mod, so now I can mess around with the diodes. Hopefully you can see here that the diodes are connected into the circuit, the sockets on one side, and then the opposite side has this alligator clip wire lead, and that wire lead is just coming over here and clipping onto the enclosure, so basically connecting the ground. And by removing or adding this clip, I can essentially pull the diodes in and out of circuit. When you see me remove the clip like this, that means the diodes are no longer in circuit. Obviously they're still physically connected, but electrically it's like they're invisible. And when I either touch alligator clip to the enclosure, or if I clip it on to the enclosure like so, now the diodes are in circuit and affecting the signal, allegedly. What we're trying to show here is that when the Klon is being used in clean boost mode, which is anywhere from 9 o'clock on the gain knob down to all the way minimum or 7 o'clock on the gain knob, that the diodes are making no difference to the sound. So that's what we're listening for, or I guess listening for the lack of right now, is any change with the diodes in and out of circuit. And also I'm going to play you a little bit when the pedal is bypassed, and you'll see me point to the LED here showing that it's off. So that's off and that's on. right, I've got a second test set up here. Hopefully I'll be able to show electronically the same thing that was demonstrated in the listening test, which is that the diodes are doing nothing in the Klon Centaur when the pedal is either very low gain or gain all the way rolled down, which is what people refer to as a clean boost mode, which is the most popular way to use the Klon Centaur. So again, we have the Seritone Centura. I have, just like in the listening test, I have the diodes connected to a wire lead that I can break or make the connection to ground for the clipping diodes. So when this lead is disconnected, that means the diodes are effectively out of circuit. When the leads are connected, diodes are in circuit. Same thing as listening test. But this time I have an oscilloscope going. So I have 2 channels and I have a wave generator or signal generator. In this case, not sure if you can read it, but the generator is putting out a 1 kilohertz sine wave at 0.4 volts peak to peak. So that's positive 200 millivolts and negative 200 millivolts. You can see that sine wave here on the yellow trace. Yellow is wired into the input jack, and the green trace is connected to the output jack. So the pedal is in bypass mode right now, so the sine waves are essentially identical. We can turn the pedal on here, and hopefully you can see the LED indicators on there now. And I can prove that the pedal is currently working. You can see as I manipulate the volume knob over here, the amplitude of the output's increasing and decreasing, and I can roll it all the way out and back up. So let's set that about unity. Unity on this volume knob is about 9 o'clock. Gain knob right now is rolled all the way down, so this will be the pedal in clean boost mode. I can roll that gain knob up, and because the diodes are in circuit, we can start to see, we get a volume boost heading up to through 8 o'clock. By 9 o'clock, I can start to see the sine wave distorting a little bit. It's starting to not, it's getting a little flatter and rounding off here a little bit on the upswing. As I push the gain knob up through 10, 11 o'clock to noon, now we're really starting to get some soft rollover on the sine wave there. And then pushing it past, the peak's starting to really curve out, and we're heading towards sort of a skewed triangle wave there. So that's gain maxed out. And we'll roll it back down to softer clipping all the way down to minimum gain. Right now, the gain knob is at 7 o'clock. That's minimum setting, clean boost mode. If we take the diodes out of circuit, watch for the change in the output sine wave there. Absolutely no change at all. Diodes are out of circuit now. Now they're in circuit. Now they're out of circuit. Now they're in circuit. So with the gain knob rolled all the way down, diodes make absolutely no visible difference on our trace. Let's roll the gain knob up to 3 o'clock. So this is 3 o'clock on the gain knob. And we can see here that our amplitude has increased a decent amount. We're now getting, it's 200 millivolts per division, and we're up 400 and down 400. So we're now essentially doubling our output voltage. We're now at 0.8 volts peak to peak, bringing the diodes. So now we can see with our diodes in, it reduces our output amplitude. So now we're only 0.6 volts peak to peak. We can pull the diodes out and the amplitude increases. But the important thing is that even when the diodes connect, let's get a good connection, clip on there. Even when the diodes connect, the actual distortion of the sine wave is not that significant. Even with the diodes connected, it still pretty much looks like a sine wave. And this corresponds well to our listening tests, that even when we were taking in and out the diode at the 9 o'clock gain level knob, the difference was basically imperceptible. So even though we can view a change on the oscilloscope here, which is a very fine measuring tool, our ears, which are much more crude, could not detect that change, and really the change is amplitude. Now obviously if we roll up the gain knob, heading up towards 12 o'clock here, it's going to bring, so I reduced made the division smaller or larger for the second one now. So that now this trace, although it looks similar, it's 500 millivolts per division for the second trace. Now if we bring in the diodes, now we can see we're getting some clipping and a lot less amplitude. If we pull out the diodes, now we have a lot more amplitude like that. This is where you're definitely going to hear it. because the sine wave is really starting to distort now from its original shape. And also you're losing all amplitude. With the diodes out, amplitude is huge because there's no clipping. And then obviously, you know, we can go up from there. So hopefully this demonstration was somewhat convincing. When the Centaur is being used as a clean boost, diodes are not making any difference to the sound, and we've demonstrated that audibly with the listening test and now electronically with a very precise measuring tool and oscilloscope. All right, so that is a wrap on my deep dive video for the Klon Centaur diodes. If you made it to the end of the video, thank you very much for watching. If you enjoyed, I'd appreciate you hitting the like button and subscribing, and feel free to hit the notification bell if you want to know when I make a new video. Given the long length of this video, there's a high likelihood that I got something wrong. So if you think I did, feel free to leave a comment. I would love to talk to you about it and be proven wrong, bringing my understanding, our collective understanding, even closer to the truth. Also, none of this video is meant to throw shade at anybody. I especially have a huge amount of respect for Bill Finnegan for his pedal, the Klon Centaur. It's a great pedal, truly a unique design in the guitar pedal world, and it inspired me to make this video. So thanks again for watching. I am Joe from Graybenchelec. I will see you next week.